let's start with condition-based actions. So I think it is reasonable for us to say that a lot of decisions that get made in the manufacturing context are made based on experience. Um, and it's because the context as well as the criteria required for making decisions are just very complex and hard to state. And it's one of the reasons why it takes 5 to 7 years to become a manufacturing process engineer in a discrete manufacturing company. It's so much to absorb. So even if you're a mechanical engineer, you're not going to be able to make decisions until you've um, acted in apprenticeship for 5 to 7 years. That means that is how much context and criteria is required. Condition-based actions is saying that that decision ultimately still is a human decision, but it should not take 5 to 7 years for somebody to become capable of making a decision. And how do we do that? Is there some other information or some other resource that can assist in us understanding that context and therefore making a decision at an earlier stage in our career? Now, we call that condition. The idea of condition, as we know, is it's all about what condition, when. So it's always about point in time, and it's about a behavior, and therefore it is dynamic. So condition, and all of us understand that in the context of industrial world, because there's a lot of condition monitoring. There's also condition-based maintenance. So the word condition is not new to us. And we've just had a tough time using condition information in our day-to-day decision making. Why? Because it's not easy to deduce conditions. And at best, we can deduce certain conditions that maybe a manufacturer has specified, or perhaps something that our uh, prior experience has indicated, has actually shown us. Now, if either of those two fall short, meaning if they don't exist, then it becomes very hard for us to understand what is the current condition. I'll give you an example. One of our customers is a steel company, and they operate blast furnaces. Now, the ambient weather conditions, such as high humidity, can affect the ore they are processing because the ore tends to absorb some of that moisture. And so, therefore, when that ore goes through a blast furnace, it can be substantially more energy intensive to process. Now, the real condition here is what? Is high energy usage in the blast furnace, high moisture content of the ore, or high humidity in the atmosphere? Well, it's actually, there is cause and effect relationship, but there are three different conditions. And this is what condition-based actions is all about. Now, when you think about that particular scenario, the way that excess energy is being used, it is going to affect your energy profile. It's also going to affect your emissions profile, because likely you're going to be using energy that may not be clean energy. And then thirdly, it is likely to impact the lining of your blast furnace, the refractories that are used in the blast furnace. And therefore, it is going to lead to more maintenance. So as you can see, these conditions, whether they are ambient conditions, raw material conditions, or equipment and process conditions, they're all going to affect these different, if you might, outcomes of maintenance and reliability, energy, emissions, and potentially also quality.